So first, let's label these. I'm going to label this as 1 and this as 2. So let's deal with 1 first. So that looks kind of nasty. We have some strange things going on over here. So on the left hand side, we have e to the negative infinity over infinity. We can reformulate this as follows. This is the limit as x approaches infinity of e to the negative x over x. And I have to say this left curly brace is ugly, so I'm going to redraw it. Well, still ugly. Okay, much better. Alright, so this will lead us to having an indeterminate form, because this is somewhat equal to 0 over negative 0 over infinity. So we apply L'Hopital's rule. And when we apply L'Hopital's rule and we have a quotient, we just take the derivative of both the top and the bottom. So this is what we'll be getting. I certainly hope I drew this thing big enough. So e to the negative x over here, and d over dx, x over here. So this would lead us to, I'm sorry that I'm going to redraw this. So d over dx, e negative x is just negative e to the negative x, and down here we just have 1. So if we take the limit, we will get up here we get negative e to the negative infinity and over 1, which is just 0. Okay, so now that we know that this part is 0, so we can just cancel it off. If I can change my pen color. So the reason why this is important is because this term over here is also indeterminate, because we do not know what the derivative of infinity over some constant is. So we can just leave that, and since this left side is equal to 0, we can just assume that 0 multiplied by anything gives us 0. So we can just ignore this left hand side term. Okay, so now let's rewrite what we have. If I can change my color, it's been really buggy recently. Okay, so we have dou PD over dou R sub D is equal to dou, I'm going to rewrite this, is equal to half. Remember, we ignored the left hand side, so we just are left with negative R sub D squared, negative R sub D squared over 4t sub D over R sub D squared over 4t sub D dou R sub D squared over 4t sub D over dou R sub D. Okay, now this looks like a bit of a mess, but we can actually easily clean this up. So the half still remains on the outside. We can take out this the negative remains, so negative 4td over R sub D squared. We have a negative e R sub D squared over 4t sub D. And now we need to differentiate this bad boy over here. So again, 4td with respect to R sub D is just a constant, so we can take this out. And we're just now doing dou R sub D squared over dou R sub D. So this is equal to, and let me just rewrite everything over here, for t sub d multiplied by 1 over 4t sub d. So this is equal to 2r sub d. So now let's look for any cancellations that we can make. There's a 4td over here and a 4td over here. There is a 2 over here, and is that a 2 over here? Yeah, indeed, that's a 2. So there's a negative sign as well. So finally, we can rewrite this as negative 1 over R sub D, because this r sub d here divided by rd sub d squared is just 1 over rd e to the negative r sub d squared over 4t sub d. Okay, so this is what we are left with from the left hand side. Okay, now let's move on to the right hand side. I'll change this to pink just for, oh, it's a really badly drawn line. Okay, so now we're doing the right hand side. Okay, so for the right hand side, what do we have? We have dou p sub d over dou t sub d. So we can apply the same concept and say that this is dou over dou t sub d. Open bracket. Well, we have a half here. We have an integral here. T sub d squared over 4t sub d infinity e negative u d over u du. Okay. So if we break this apart using a similar logic to the previous question, what we'll get is we can take out the half over here. We can just open the brackets over here. So again, we have negative e to the negative infinity. We have dou infinity here, but over dou td this time. Subtracted by e to the negative r sub d squared over 4 t sub d, r d squared over 4 t sub d, dou r sub d squared over 4 td over dou t sub d. Okay, so we already know that this term ends up going to 0, so this term just cancels out to 0. So what we are left with is, so we need an equal sign here, we are just left with half negative, again, negative 4 t sub d over r sub d squared, slanting now, e r sub d squared over 4 t sub d. So here we can actually take out some factors. We can take out an r sub d squared over 4 dou 1 over t sub d over dou t sub d. Okay, so now let's simplify this. Let's look for terms that, oh, let's actually just do the derivative first. So negative 4 t sub d over r sub d squared e to the negative r sub d squared over 4 t sub d r sub d squared over 4, and this comes to negative 1 over t sub d squared. Okay, so 4, sorry, not the whole thing. The rd squared cancels, the rd squared, the 4 cancels out with the 4. Okay, and let's see here. So we have a td squared over here, and we have a td over here. So we'll end up with some factor of td in the bottom. So this is what we're left with. So we still have the negative there. So we have a negative 1 over 2 t sub d e to the negative r sub d squared over 4 td. Okay, so now here I realized that I may have made a mistake in the earlier part. So yeah, there should be some kind of a mistake over here. Okay, yeah, so this is the mistake. Well, okay, to be honest, it's not yet a mistake because I haven't completed the steps yet. Well, that's fine. So, never mind. Let's actually just move on to the next part. My lines are really bad for some reason. So what we have shown is that dou p sub d over dou r sub d is equal to negative 1 over r sub d e to the negative r sub d squared over 4 t sub d. And we've also managed to show that dou p sub d over dou t sub d is equal to 1 over 2 t sub d over multiplied by e to the negative r sub d squared over 4 t sub d. Okay, but remember, going back to the diffusivity equation, which I'm going to write in orange this time, was 1 over r sub d dou over dou r sub d, r sub d dou p sub d over dou r sub d. This was equal to dou p sub d over dou t sub d. So what do we already have? Well, we already have this done, but this is not actually 1 over dou rd dou over dou rd, rd dou pd over dou rd. Okay, so let's actually look at how we can break that. I'll use white again. 1 over sub d dou over dou r sub d. So we have an r sub d here, and this is negative 1 over r sub d e to the negative r sub d squared over 4t sub d. So let's see what cancels out. These already cancel out, the r sub d terms. So what we're left with is 1 over r sub d dou over dou r sub d negative e to the negative r sub d squared over 4t sub d. So now all we need to do is differentiate this term with respect to r sub d, which is simple enough. What we'll get is, so again, we can take out some constants over here. So we'll get negative, or at least, yeah, it is negative 1 over 4t sub d multiplied by negative 2r sub d multiplied by e to the negative r sub d squared over 4t sub d. Okay, that's a bit of a mouthful. So these cancel out, r sub d's cancel out, 2 over 4. Finally, we have 1 over 2t sub d e to the negative r sub d squared over 4td. Well, this is our left hand side. What was our right hand side? Well, it was the exact same thing. So we have managed to show that this is the right hand side, and we've also managed to show that it's the same as the right hand side. Therefore, left hand side is equivalent to our right hand side, QED. And that's it. We have demonstrated the agreement between the radial diffusivity equation in dimensionless form with the dimensionless solution, exponential integral solution. Okay, please, if you liked the video, please leave a like, comment, subscribe, and click the bell notification for icons. Thank you for watching, and stay tuned for more. Bye.